All right, so elimination reaction is basically when you produce an alkene from halogenoalkane. We've studied the
Okay.
production of halogenoalkanes. Any alkane or an alkene that has a halogen group attached to it. And obviously, once
Yeah.
you eliminate that halogen group from the alkane, it will turn back into an alkene. Why not an alkane and why an alkene? Because of the number of bonds. Let's just write it down that when a halogenoalkane gets converted into an alkene, that is an elimination reaction. Example, CClH. So for example, if this compound here has one chlorine, if you let's say remove this chlorine, so this bond here, let's say this is the first bond and the second one is that's the second red bond. So once you remove this Cl, you'll definitely be closing these two bonds, right?
Okay.
Because obviously
Yeah.
there's one free bond and you won't just be removing this chlorine, you'd have to remove the hydrogen as well in order to close the two bonds. Otherwise, you won't get an alkene. Yeah. So two C's
Okay.
now. There are two hydrogens here, and they just close down to make this alkene. Plus, there's going to be one hydrogen left, this one, and you'll be left with HCl because this hydrogen, let's say if you're removing this hydrogen, this chlorine, they're going to make HCl. So in an
Okay.
elimination reaction, you get an alkene from halogenoalkane and HCl as a byproduct. Because obviously you'll have to remove one halogen and one hydrogen to get that double bond. By just removing the chlorine, you won't get a double bond here. So that's not possible because technically it doesn't fall into the molecular series of alkane or alkene if you remove just one halogen here. So it's important to remove one hydrogen as well to get a proper alkene. So,
Okay.
okay, and the conditions for this reaction are NaOH ethanolic with reflux. If you remember, while performing the nucleophilic substitution reactions, most of our for the displacement of Cl with OH, NaOH used to be the reactant, right? But in that case,
Okay.
NaOH was aqueous. For elimination reaction, the NaOH that you use is ethanolic. This is the difference here. You will be asked about these questions most of the times in the MCQs that when do you use NaOH ethanolic and when do you use NaOH aqueous? You should know that NaOH aqueous is used for nucleophilic substitutions, whereas NaOH ethanolic is used for elimination reactions along with reflux. Reflux is common for both of these reactions.
Okay.
All right. Okay, that is it. I'll give you a few questions to practice these eliminations after this lecture. Let's
All right.
talk about the reactivity of halogenoalkanes now. So technically, we know that the bigger bond is generally more reactive because of its bond strength. Because the bond strength is weaker, the electrons are far apart. See,
Yeah.
I'm going to draw this diagram again. There's a difference between the radii of these two atoms. The first one has a smaller radii, whereas the bigger one the second one has a bigger radius. So obviously the second one is more reactive. Why? Because of the weaker bond strength. And why is the bond strength weaker? Because the electrons are far apart from the nucleus. Let's say if this is the nucleus here, the
Yeah.
electron in the valence shell is far apart from that nucleus. The attractive forces are weaker and it's easier for that electron to get displaced. This is why,
Okay.
reactivity is when an electron of an atom I mean, it's when it's easier for the atom to lose its electron or easier for the other one to gain the electron. So the reaction or the loss and gain of electrons is all, it's all what reactivity is. So an atom is reactive if the electron is easily lost, and it's reactive if an electron is easily gained. This is why these bigger molecules having bigger radii are generally more reactive because of their weaker bond strengths. Okay, if you look at the halogens, the group 7 elements now, if let's say the carbon is bonded to a fluorine or a chlorine or a bromine or an iodine, the bond strengths will, for all of these bonds, will be different. A carbon with the fluorine will have the strongest bond. Why? Because fluorine's atomic radius is the greatest. Sorry, smallest. Bond is strongest, the reactivity is weakest. So it's the least reactive one. Whereas iodine, the bond is weakest bond and the most reactive one. Why? Because fluorine over here is on top of the group. The atomic radius of fluorine is lesser as compared to these other halogens. Because of the lesser atomic radius, the bond is strongest and the reaction is, it's the least reactive one. Similarly, iodine is the one that has the greatest atomic radius. This is why the bond is weakest, and this is why it's the most reactive one. And the radii they tend to get bigger as you move from CF to CI. Cl, CBr, they have these medium-sized atoms. So this is an example of a bond with CF, CH3 and CF. This bond is the strongest there. So this is why it's the least reactive. Similarly, if you look at a bond with iodine, this is an example. It is the weakest bond because Ci is the most reactive one. It is the most, this reaction is the most strongest there. Identification of halides now. Halides are these ions, the halogen ions. Chlorine is a halogen. Cl negative is a halide. Similarly, bromine is a halogen. Br negative one is a halide. And a chlorine, halide of chlorine is known as a chloride. We already know this. Bromine is known as a bromide. Iodine is known as an iodide. So our halides are all the ions, negative ions. So CH3Cl has a chloride attached to it, a Cl negative one. Yeah, so we should know how to identify these halides as well. Let's say, I mean, if you have this compound given, you would have to test this to understand whether it has a chloride, a bromide, or an iodide. The test that we perform to identify the halide is the AgNO3, the silver nitrate test. AgNO3 along with NH3. So these are the two compounds that we use to test the presence of halides. And this test is known as the hydrolysis test. Hydrolysis with AgNO3 and NH3. Once you react AgNO3 and NH3, if let's say a Cl negative ion is present, it will give you a white precipitate. This is the identification with AgNO3, okay? And NH3 would cause this Cl negative one to dissolve. And it will dissolve in dilute NH3. Let's say if we have a Br negative one ion present, a bromide, it would give a cream precipitate with AgNO3, and it would dissolve in concentrated NH3. It will not dissolve in dilute NH3. Similarly, if let's say we have an iodide negative one ion, it will give us a yellow precipitate with AgNO3 and it will not dissolve in either dilute or concentrated NH3. It's not soluble.
Okay.
This is how you can use HNO3 together with NH3 to identify these halides, sir.
Okay.
Okay, so first of all, this hydrolysis basically dissociates this halide from the compound. It will cause the halide to get displaced, and this is how it will give the colors. The colors are due to the differing bond strengths. Because the Cl negative one has the strongest bond, this is why the color is white, and as the bonds decrease, the color tends to get darker. So this is how I negative one will give you yellow precipitate, and you can just write it down. What hydrolysis does is that first of all, it will liberate the halide ion.
Okay. Wait, see.
Secondly, the colors are different due to the differing bond strengths.
Okay.
And similarly, yeah, because I has the weakest bond, the reaction is the strongest. All right. Okay, we're done with this. Let's keep it till here. Yeah. I think we should
Okay.
practice a few questions now. I can give you some time to maybe write the information down or copy the notes,
All right.
and
Okay.
then we can move on to the questions. I've shared the assignment with you.
Yeah, I've seen it. I'm just
Marking scheme as well.
finishing it. Yeah, I've copied it down. Should I just attempt the assignment now?
Yes. So the markings, I've also shared the marking scheme. What you can do
Okay.
is you'll find a lot of the questions similar to the previous assignment because obviously the questions are a
Yeah.
little bit stuff. You'll also get a few questions from isomers, from the mass spectrometry. Okay. It's good because, I mean, since we've done the syllabus, it's good that you revise all of these.
Yeah.
Essays. So try to get done with first 4 questions in the next half an hour, maybe. And
Okay.
then the remaining questions as a homework. Okay. You
Okay.
can keep checking your answers against the marking scheme and let me know if there's anything that's difficult. I
Okay.
am here to respond to your queries on WhatsApp. I think I'll end the meeting now because it's just going to get, I mean, we do have a time limit as well. So I'll just stop the screen sharing and the recording in the meeting. In the meantime, you can
Yeah.
just continue attempting the assignment. Let me know if there's any question that's difficult on WhatsApp.
Okay.
All right.
All right then.
Oh, okay then. I'll see you. Okay. Bye.
Okay. Right. Take care. Bye.